Yes, students, today we'll do memory interfacing with 8085 microprocessor and EEPROM. As I told you, EEPROM means it's a part of ROM, so it will do only read-only memory. The problem is interface an 8 kilobyte of EEPROM with 805 microprocessor using number 1 NAND gates, number 2 decoder, such that the address range allocated to the chip is 000. H means hexadecimal, and 1 FFFFF H means hexadecimal. Okay. So solution to this is, first you have to find how many address lines is needed. So for an 8 kilobyte of memory, you need 2 to the power 13. That will give you 2192 memory location. So generally this is being interpreted as 8K. Okay, they just round it off to 8K, and you need 13 address lines. Okay, so for this, since 8085 needs not needs, it has 16 address lines. So we'll write and we have to interface this 13 address lines with the 16 address lines of 8085. So we'll write it this way: A15, A14, A13, A12, A11, A10, A9, A8, A7, A6, A5, A4, A3, A2, A1, A0. 16, A0 to A15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So since it needs 13 address lines, means A0 to A12 will be 13 address lines. So this will take full range from 0000. Okay, then it will go 0001, so on and so forth. So I just write dot dot, so on and so forth to 111, 1111. Okay, 13 address lines. So since it's already defined that your address range should be from 00 to 11F. So to get 0, so you get the address range as 00 hexadecimal. This will be 0001 hexadecimal dot 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 to FFFF to 1 FFFH. To fall in this range, we have to make this as 000 000 000 000. Okay, so in hexadecimal, if you combine this, there will be 4. So 001 is 1. This will be F, this will be F, sorry, not here, this will be F, and this will be F. Okay, to fall in this particular range. So a diagram for this, using, first I'll implement it using NAND. So we'll draw an 8085 here. This is an 8085 microprocessor. Okay, it'll have an address A0. This, let's take this as your EEPROM. This as a EEPROM. Okay, so your address from A0 to A12, that is 13 address lines, will accumulate it here. Address A0 to A12 will accumulate it here. This is just a group of lines. Whereas the 3 other lines will pass it through a NAND gate. So from 8085, it's being given as 000. So it becomes 000. So we have to, because all these other lines, first of all, we have to identify these lines will be used for address lines. Okay, these lines will be used for chip select. So generally in EEPROM, always the chip select is generally active low. Okay, so it goes active low means you have to, if you have to pass it to a NAND gate, means it has to be, to get a 0 here, you have to put 1 1 1 here. Okay, so this is how you interface your 8085 with your EEPROM using a NAND gate. This is your NAND gate. Okay, you can write extra lines here, D0 to D7, D0 to D7. Okay, and because it's a read-only memory, so you can write your this will be your OE signal. OE signal means it's your read. Okay, so you can activate your memory read signal, which is generally an active low signal from your 8085 microprocessor. So this is one diagram, the first one. The second one using a decoder is similarly to this. I'll draw an 8085 here. This is an 8085 microprocessor. Okay, this time I'll use a decoder. So since there are 3 address lines which I have to use, so I'll use a decoder which have 3x8. 3x8 means 3 inputs, 8 outputs. So your output goes from Y0 to Y7 with 8 outputs. Okay, but since here 0 0 0 means Y0 is chosen. Okay, if you put here 1 1 1 means Y7 will be the Y7 output will be chosen. So this Y0 will go to an EEPROM, will be fed to a chip select of an EEPROM, and the rest will be the rest of this will be open, and so the address lines will go this way. This is A0 to A12. By the way, this is your EEPROM, and this will also be A0 to A12, and similarly this will go as your D0 to D7. Okay, and these are your A13, A14 and A15. Similarly here A13, A14 and A15. That's how you solve this memory interfacing of 8085 with an EEPROM. Okay. Thank you.